All right. So area by definition is length times width. All right. So that's area of a rectangle. Not all areas are length times width, but in the case of a rectangle, it would be. They gave us the dimensions of x and y. So area is equal to x times y. All right. I'm not writing that in part A yet because it says we need a function for the total area of the page in terms of x. So having a y in there would be a problem. All right. They told us that blue region is 30 square inches. So that's our print. All right. So the area for just this part is going to be 30. All right. So I need dimensions for this part and this part. All right. If I know that the entire, so I'll just kind of like put it up here. If I know that the entire side is x and I'm subtracting off 2 over here and 2 over here, then that middle part would be x minus the 2 2's that I subtracted. So that middle part would just be x minus 2. All right, so that's x minus 2 for this dimension here. All right, the same would be the case for the vertical side. X minus 4, thank you. All right, so the other side, total length of y, we're subtracting off a 1 here and a 1 here. So this other side would be y minus, that one would be a 2. All right. So to find the area of that blue, well, we already know the area of that blue region, but to find the dimensions that lead to the area, we would have, again, an area is length times width, x minus y, x minus 4, sorry, y minus 2, that's going to be equal to the 30. All right. Now, this is a unit on rational functions, so it's natural to expect there to be a rational function in this equation somewhere. All right. What I have here are 2 equations with 3 variables. One I'm going to leave as a variable, the area A. The other is x, which is what my area function should be in terms of total area A in terms of x. So I should have an A and I should have an x. I need to get rid of the y. All right, so I'm going to focus my attention on this equation, solve it for y. I'm going to divide out the x minus 4. That's going to get me y minus 2 is equal to 30 over x minus 4. I'm going to add a 2 to both sides. And get y is equal to 30 over x minus 4 plus 2. All right. So now I have an expression that relates x and y, which means that I can swap out the y in my area function for this monstrosity of an expression, but at least it has an x in it instead of a y. All right. So I'm going to make that substitution. And that'll get me my area function, which is what they're asking for in A. So it's going to be A of x is equal to x times, instead of just a y, it's going to be all that. So 30 over x minus 4 plus 2. Don't distribute, don't simplify in any way. This goes right into your calculator, all right? So we'll put that in. In part B, it's saying find the practical domain. And honestly, everywhere where I say find the practical domain, I really mean find a practical domain, right? So, because that's what it is, especially for some of the other problems, which you'll say that the practical domain is a value from 0 to some reasonably large number. And I would say, for example, 0 to 24. You might say 0 to 20, and you'd still be right. All right, so as long as you find a practical domain, you're good, all right, based off the physical constraints. Now, in this case, you could probably avoid the whole physical constraints part if you just look at this function here. If I put a value in for x that is equal to 0, the whole thing zeroes out. But if I put in something less than or equal to 4, I'll have a problem. Because if I put a 4 in for x, I'll get something undefined. All right. If I put in something less than 4, I'm going to get a negative. All right. Depending on how big it is, but it's still going to give me a negative value, and we're not expecting negative areas. All right. So my practical domain would start off with some value bigger than 4, and yes, some reasonably large number. Now, I'm writing reasonably large, and then I'll throw an example in there of what would constitute reasonably large. If you just give me parentheses 4, comma, and then actually give me a reasonably large value, then you're fine. So if you go 4 to 10, 4 to 20, whatever, that's fine. All right. We're just not saying 4 to infinity because that's not practical. All right. That's the important, one of the important takeaways here. All right. So I put in my function. The one time having an x built into the actual function kind of worked out. But again, the calculator understands order of operations better than we do. Right? It's programmed to. So don't simplify. You might make a mistake. Just type it in exactly how you have it on paper. And one of the benefits, it's benefit/trade-off. On a test, if you come up with the wrong equation, but then put that equation in your calculator, I can at least follow in my calculator what you did using your equation and see if you came up with the right value. If that's the case, it might only be a half a point deduction. All right. If you go simplifying, you kind of muddy the waters. It's possible that you put something into your calculator that's not equivalent to what you wrote down initially, in which case I can't figure out where you went wrong. It's too confounded. All right. So just be careful about that, obviously, but don't even bother simplifying them. These kind of questions are designed for you to not have to worry about the algebra. All right. I'm going to go to the graph, put it on auto. I mean, unless it gives you, based off of the last window that you had, unless it gives you something like picture perfect, which this one kind of is, you're probably going to want to go to auto and play around with the window. I'll select auto because we can't assume we're all in the same spot. We get a lot of graph here that's not relevant to what we're looking for. All right. So I would go into axes. For values of x, I'm going to make my low bound 4. And my upper bound, I'll put in, I think I said 10 before, I'll put in 10. It may not be big enough. That's all right. I'm going to leave y values on auto. It actually gets the job done, I think, for the most part. We're looking for the minimum. It says the least amount of paper used. So as long as I could find a minimum here, I'm good. I might have to go a little bit further. You're just looking for that black dot. If you find that black dot, I never wanted this to be like an eye test, but if your high bound for your domain it puts you in the right area, you should be able to find that black dot that represents the minimum. Now, if you want to convince yourself that it is in fact the minimum, then you're probably going to want to go out further. So I'll do like, instead of 0 to 10, I'll do 0 to, let's say 100. 20 would have got the job done, but I'll put in 100. My values of y I'm going to leave on auto. It automatically shifts those values for you. So I get a little extra graph that I don't want, but I have enough to show that this is a minimum. It looks like it's coming down, grabbing that point, and then turning around before starting to increase again. So I've convinced myself that it's a minimum. And 0 to 20 would have got the job done because you see 20's to the right of where that minimum is. So as long as you pick some number that's bigger than where that minimum is, that it's like roughly 11, then you're fine. So I'm going to say 4 to 20. Yeah, seriously. Well, it's a stretch, but I'm going to just make the graph look appropriate to what I selected. Ooh, that looks hideous. 100 was better, actually, or more appealing to look at. If you really want to go crazy, you put in like 1,000. You can put in 500, whatever you want, and that'll show that there definitely is a minimum. But then it's so zoomed out that it's kind of a mess. So 100 ended up being actually pretty okay. So, it's a little guess and checky, but it gets the job done. And as long as you have something that gets the job done, you're good. Now, you might say, well, did I have to bother with that? If the black dot showed up, couldn't I just pull that? Yes and no. You're kind of taking a chance because that black dot could be a minimum or it could be a maximum. So depending on what part of the graph you're on, it might actually give you a maximum instead of a minimum. All right, so you just got to be careful, but, worst case scenario, like time's running out on a test and you just need an answer, just find the black dot and hope for the best. All right. I'm just going to get this in here real quick. And like I said, I went 0 to 100 instead of 0 to 20. This calculator stuff that I do, where it might seem like, all right, he's spending an awful lot of time on this. There's a reason behind it. It's not really anything more than I'm putting myself in the shoes of a student that's in the middle of taking a test and freaking out over, like, I just can't get a window to work. What do I do? All right, so that's all it is. If you're able to come up with windows, like viewing windows on your calculator fairly easily, and this feels like a waste, then it probably is a waste. But there's definitely at least a couple of people that are like, I get everything. The only thing I can't seem to figure out is how to come up with a good window to look at my graph. Because as you can tell from what I've been showing you, that's the most efficient way, the quickest way to come up with minimums and maximums. If you go into the Calculate menu, under Find, if you hit the button the right way, Find, you'll see minimum and maximum. You'll also see zeros, tangent, integral. You don't know what those are yet. But if I select maximum, you'll see at the bottom, I know this one was asking for minimum, it says no maximum found in this window. So emphasis on the in this window part, all right? But if I go to find the minimum, so maybe you just can't find that black dot and you want to know if you're in the right window, minimum, it'll bring you to that minimum, all right? The other thing that you can do, I'm just kind of putting myself in your shoes again. You're taking the test, you come across a black dot, and you're like, is this a minimum or a maximum? Go into that calculation menu and select minimum and see if it brings you to that black dot. If it doesn't, then you probably found the wrong one, all right? So just like little tricks of the trade. There's some tricks for the TI calculators too, if we need to look that over. I know a couple people like to use the TIs, so if we want to look that over, we can. I'll work with those individuals separately, though. All right. What should the dimensions of the page be so that the least amount of paper would be used? We found the minimum at 11.74597. 6898387, I think. All right. That's the minimum value of this function. We just have to tie it to what the question's talking about, because it says the dimensions of the page be. All right. So the entire page is X by Y. All right. So do they say width and length? Yeah, reasonably enough to assume that the width is your X value. No rounding instructions. Be careful. Just whatever the question says to round it to, round it to. We'll go to nearest tenth. It's pretty typical. 11.7, I believe it was inches. The length, that's the Y value, which was 30 over x minus 4 plus 2. All right. So we have a little bit of algebra. Well, it's a computation. We have to plug the 11.7-ish in for x and then solve. So I'll go to my calculation app. 30 divided by my 11.74597 minus 4. Tend to put the unrounded value in just to get as much accuracy as we can get. And we get 5.8. 5.9, thank you. 5.9 inches. So these are the dimensions of the entire page that we would need to have in order for the print to have an area of 30, right? And I'll just show the quick extra step here. It's not anything they asked us to do, but if I tell you that the entire length of y was 5.9-ish, and the width was 11.7-ish, we have a print on the inside that's four less. I realize up here I never made that change. You corrected me, but I never fixed it. 4 less than whatever the overall length is. All right, so 11.7 minus 4 is going to be 7.7-ish. All right, by 3 because we subtract 2 from the length, 7.7 times 3.9 gives you around pretty close to 30, which is what we are ultimately looking for. All right. So, like how many pieces of paper are exactly 11.7 by 5.9? 8.5 by 11 is your standard sheet, right? 11 by 17 things, but they all tend to be rounded values. But that, you could get weird numbers. I don't know if they'll be this weird, but you can get some weird numbers. But also, I would say most of the time, whenever you see weird dimensions in terms of like pieces of paper or objects, and it's like, well, this one is 11.7 inches. It's probably because it was a metric value that was just converted over, right? So it's probably a nice, clean metric value, but when converted over into the standard units, it became hideously disfigured, right? But, like I did a lot of extra hand waving and writing, jotting information down and stuff like that. But really, the calculator did everything about this problem that was difficult. The problem is you wouldn't necessarily appreciate that till you take a calculus class and you have to do all this by hand. And you're like, oh, that calculator really did save me a lot of time. Because I would say probably another, in order to get full credit on the calculus solution for this, probably another 10 minutes of work. Right, so a good amount of writing, probably like a full page of writing, right, if you're organized. So the calculator's cutting out a lot of stuff here, so that's good. And not that anybody asked, but my rationale behind showing you this, aside from it being in the curriculum, but when you're in a calculus class and you do have to do stuff by hand, but you're allowed to use a calculator, you just can't let the calculator do the work for you. But you can let the calculator tell you what the answer is supposed to be before you even get started with the calculus. All right, so that's really the power of being able to use a calculator appropriately. All right.